In my sort of trawling through various information sites, I came across a website, Earth System Science Data, and came across an article with the headline, Heat Stored in the Earth System 1960-2020, Where Does the Energy Go? And there's a lot that I don't understand because there are all sorts of figures and equations that are meaningless to me, but the opening sentences are easy to understand. The Earth climate system is out of energy balance, and heat has accumulated continuously over the past decades, warming the ocean, the land, the cryosphere, and the atmosphere. And the Earth energy imbalance, let me just find where, okay. So the heating rate over the last 60 years, 89% of that extra heat is stored in the ocean, 89%, followed by about 6% on land, 1% in the atmosphere, and about 4% available for melting the cryosphere. And the cryosphere is that part of the globe that has solid precipitation on it. So snow and sea ice and lake and river ice and icebergs and glaciers and permafrost and all that sort of thing is the cryosphere. Professor Guy Midgley, Acting Director at the School for Climate Studies at Stellenbosch University. Guy, good afternoon.
Hello, John. You have a very interesting reading pattern. Amazing.
It does take me down some dark holes and some filled with light. I mean, it struck me, look, this is not something I know much about at all, but it did strike me that all this accumulated heat over the last 60 years, and 90% roughly of that is stored in the oceans. Are we taking ocean warming seriously enough?
Well, it's an incredible set of numbers, and the 4% that has melted ice. You know, of course, all that saves us from a more rapidly warming atmosphere. So only 1% is warming the atmosphere. So the atmosphere is really the tail of the story, and the value of this kind of work is partly to show how long it will take to cool back down again once we get greenhouse gases under control, because all the additional heat that's stored in the ocean will gradually leak back out again as we come back into equilibrium. And that is very, that's frightening. There's a momentum that we are fighting against.
And with that momentum, these statistics, I don't know how new these statistics are. I don't know how more alarming they are than what was previously known. But I mean, I read something like this and I don't understand the equations. I don't understand the formulae. But I do think, does this mean that low-lying islands are going to be flooded more quickly than has previously been thought? And the only good part of that is that maybe the Guptas would be drowned in Vanuatu, but I can't think of any other positives.
The sea level rise is probably dialed in no matter what over the next few decades. And, it's for this reason that people, that we should be planning already proactively for, at least 50 centimeters of sea level rise by the end of the century. So we could immediately start doing some very important planning in low-lying areas. Because no matter what we do with the atmosphere, that is very, very likely to happen. But it's also, the science shows a maturity now where we're able to do this work at a very high degree of resolution. And, for example, fight denialists of things like glacier melt who say that, the Arctic is balancing out the rest of the world and it's gaining ice. Well, no. If you look at the energy balance, that's absolutely not true. And so it really it removes all the wiggle room from people who are arguing that climate change is not an issue.
And what you started by saying, Guy, is that it tells us how much longer the ocean is going to take to lose that heat, which is currently stored there. Is there anything in that we need to take serious notice of?
Yes. It just means that the rate at which we can start to return the world back to a safer temperature is low because of this buffering capacity. The buffering capacity saves us on the way up but it also slows down the recovery on the way back down again. That is the core issue. The energy that melted ice saved us from additional warming, but it caused sea level rise, and it will be much harder to recover that on the way back down again. So it's an indication of the relative irreversibility of the decisions that we take over the next few years for the following 3 to 4, 5, 10 decades.
Professor Guy Midgley, thanks for talking to us, and in a way that I could understand, Acting Director of the School for Climate Studies at Stellenbosch University.